Hi, this is Dylan Compton coming to you live from Hampshire College. Actually, it's not very live, it's recorded. This is my first video diary ever, and I hope I do okay and you guys find me engaging and useful in some manner. I study artificial intelligence and all sorts of other nerdy science type things, and as a student concentrating in these areas, I have access to a significant amount of news in science and technology and health and computers that a lot of people don't ever hear because it doesn't enter the mainstream media. So I thought it would be interesting to bring to you via this video diary, which will continue, summaries of current interesting research and technology innovations that are occurring all around us that very few people ever hear of. I think first on our agenda tonight is something which I personally think is really cool, which is the cloak of invisibility, or at least the beginnings of the research for it. Researchers at Purdue, since they've been working with this light stuff for a while, have developed a piece of technology which lets them bend single wavelengths of light around an object. Well, that sounds, maybe that's not so hard. It actually is pretty difficult, and what it does is prove the concept that you can bend these wavelengths of light. Basically what this means is that after some additional research, within the foreseeable future, probably within about 10 years is what they're estimating, you'll be able to bend all wavelengths of light around a target, around an object, which means that individuals looking at you would not see you, or the object that was being cloaked. However, they would see what was behind it, and if they were behind it, they would see what was in front of it, because the light is actually bending around. It's not ever hitting the subject, so therefore you can't see it. Really cool stuff. What I'm going to talk about now, and probably most exciting to me, most exciting to you, and what I'm going to spend most of my time on, if I've not already been long-winded and boring enough, is the discovery of, or rediscovery rather, of dichloroacetate, DCA for short, which is how I will refer to it. Dichloroacetate is a drug that was developed to treat metabolic diseases in patients years ago, probably 30 years ago now, by major drug companies, and it's been used. It's very cheap to produce, and it is basically what it does is it restarts or aids in the function of mitochondria in your cells. What this means is that your cells produce energy normally when it's under the effect of dichloroacetate, because basically what it's saying is, telling your mitochondria to do what they do best, which is give you your energy, your adenosine triphosphate, which is basically the little batteries that float around in your blood. So one of the problems with cancer cells is that they don't die. And the reason they don't die, as they've recently discovered, is that their mitochondria don't give them their energy. It's a process called glycolysis, and what happens in your normal cells that die is that the mitochondria stop functioning and your cell dies off. In a cancer cell, since the mitochondria were never functioning and they're using glycolysis to get all of their energy, they don't die. They just keep growing, and they don't grow as efficiently as your normal cells, but they grow, and they swell, and they kill you. So what dichloroacetate does is it goes in, and when it's applied to cancer cells, it restarts their mitochondria, and they lead a normal cell life, and then they die. The second really cool thing about it is that because it was already approved by the FDA for use as a medicine 30 years ago for metabolic diseases, the time we're looking at for clinical trials of this on humans is in the next 1 to 2 years, so probably by 2010 at the latest, rather than the 8 to 10 years of lab animal testing that we could expect to proceed a 2 to 3 year review process by the FDA before it could finally go into clinical trials if it was a brand new drug. The third thing is, and this is a positive and a negative, that because it's already been patented and that patent has now expired, no major drug company will be able to hold the monopoly on it, which means that because it is easy to produce and cheap to produce, they will not be able to overcharge for this. This is a treatment that's going to be affordable and accessible. However, The downside of this is that because of that fact, because there is no patent, because there is no monopoly available, the drug companies aren't funding the research. The research was initiated at University of Alberta, and they've proven that this works on rats and other lab animals with tumors. However, it's all being privately funded or funded by the government of Canada at this point. They're actively seeking other sponsors. NSF, I think, is doing some contributions some other places, but because they don't have a major drug company to fund the research, it's very, very hard to get this research done. If any of you are interested, if you Google dichloroacetate research or University of Alberta cancer research, anything like that, they have a website up to contribute money, etc., etc., etc. But, in my opinion, one of the coolest things, curing cancer has been the kind of holy grail of the medical community for a long time, and it's right around the corner. So, I think I'm about out of stories for now, but I guess I'm signing off, and I will see you all in a couple weeks when I have another build-up of interesting, esoteric, and unknown news from the science and technology community.